Chapter number 2, Quadratic Equation. This is Mrs. Bean. She is relaxing at a resort in Goa and planning about owning her own resort in near future. So she is thinking, what might be the area of this resort, which is 20 times the area of the swimming pool, and the side of the swimming pool is 1/3 of the breadth of the resort. Also, the length of the resort is 10 meters more than its breadth. She can calculate the area of the resort using quadratic equation. An expression which can be expressed in the form of ax square plus bx plus c is equal to 0 is a quadratic equation where a, b and c are any real numbers and x is the variable. Highest power of the variable in a quadratic equation is 2. Here a is equal to 0. If a is equal to 0, then the equation is not a quadratic equation. It becomes a linear equation as the power of the variable is 1. Some examples of quadratic equation. This is a quadratic equation. Comparing it with the general form ax square plus bx plus c is equal to 0. We get a is equal to 3, b is equal to 4 and c is equal to 5. Here, the third term c is missing. We can write the given equation as x square minus 5x plus 0 is equal to 0. On comparing with ax square plus bx plus c is equal to 0, we get a is equal to 1, b is equal to minus 5 and c is equal to 0. This is a quadratic equation where b is equal to 0. Roots of quadratic equation. Values of the variable that satisfies the given quadratic equation are called roots of quadratic equation. For example, consider x square minus 4x plus 3 is equal to 0. Let us substitute the value of x as 1 randomly in LHS. Therefore, x square minus 4x plus 3 is equal to 1 square minus 4 into 1 plus 3, which is equal to 1 minus 4 plus 3. Therefore, 4 minus 4 is equal to 0. Therefore, RHS is equal to LHS. We say x is equal to 1 is the root of x square minus 4x plus 3 is equal to 0. Now let us put x is equal to 2 in LHS. Therefore, 2 square minus 4 into 2 plus 3 is equal to 4 minus 8 plus 3, which is equal to 7 minus 8 is equal to minus 1. We get minus 1, which is not equal to 0. Therefore, LHS is not equal to RHS. Therefore, x is equal to 2 is not the root of this given quadratic equation. We call it as trial and error method. Note, by substituting arbitrary values for the variable and deciding the roots of quadratic equation is a time-consuming process. Therefore, we can use another method to find roots. Methods of solving quadratic equation. Number 1. Factorization method. Number 2. Completing square method. Number 3. Formula method. Factorization method. Let us see this method with help of an example. X square plus 6x plus 8 is equal to 0. General form of quadratic equation is ax square plus bx plus c is equal to 0. Here, a is equal to 1, b is equal to 6 and c is equal to 8. We find out two numbers p and q such that their product is equal to plus 8 and their sum is equal to plus 6. We can take p is equal to 4 and q is equal to 2, as 4 into 2 is equal to 8 and 4 plus 2 is equal to 6. Now, we split the middle term 6x as 4x plus 2x. Our equation becomes x square plus 4x plus 2x plus 8 is equal to 0. We can take x common from x square plus 4x and similarly 2 common from 2x plus 8. X into x plus 4 plus 2 into x plus 4 is equal to 0. Therefore, taking x plus 4 common, it will become x plus 4 into x plus 2 is equal to 0. Therefore, x plus 4 is equal to 0 or x plus 2 is equal to 0. Therefore, x is equal to minus 4 or x is equal to minus 2. Example: minus x plus 3x square minus 10 is equal to 0. First, we rearrange the equation. We get 3x square minus x minus 10 is equal to 0. Then, comparing with ax square plus bx plus c is equal to 0, we get a is equal to 3, b is equal to minus 1 and c is equal to minus 10. First step is to multiply coefficient of x square with c. We get the product as minus 30, which is 3 into minus 10 is equal to minus 30. Now we find two numbers such that their product is minus 30 and their sum is minus 1. Therefore, minus 6 into 5 is equal to minus 30 and minus 6 plus 5 is equal to minus 1. Therefore, splitting the middle term, minus x is equal to minus 6x plus 5x. Our equation becomes 3x square minus 6x plus 5x minus 10 is equal to 0. 3x is a common factor in 3x square minus 6x and taking plus 5 common in 5x minus 10. Now, taking x minus 2 common, we get x minus 2 into 3x plus 5 is equal to 0. X minus 2 is equal to 0 or 3x plus 5 is equal to 0. Therefore, x is equal to 2 or x is equal to minus 5 upon 3. Solve these for practice. Completing square method. Let us consider previous example. Step 1. Here coefficient of x square is already equal to 1. X square plus 6x plus 8 is equal to 0. Step 2. Solve 1 by 2 into coefficient of x whole square. Here the coefficient of x is 6, which is b. So 1 by 2 into 6 whole square is equal to 3 square is equal to 9. Step 3. Now add and subtract this value on left hand side of the equation. X square plus 6x plus 9 plus 8 minus 9 is equal to 0. Now select the first three terms to get a perfect square. Now x square plus 6x plus 9 can be written as x square plus 2 into 3 into x plus 3 square, which is nothing but x plus 3 whole square. Therefore, x plus 3 whole square minus 1 is equal to 0. Shift the term, a part of the perfect square, to the right hand side. X plus 3 whole square is equal to 1. Take square root on both the sides. Square root of x plus 3 whole square is equal to square root of 1. X plus 3 is equal to plus minus 1. Therefore, x plus 3 is equal to 1 or x plus 3 is equal to minus 1. Therefore, x is equal to 1 minus 3 or x is equal to minus 1 minus 3. Therefore, x is equal to minus 2 or x is equal to minus 4. Hence, we get two roots of quadratic equation. Example, 9y square minus 12y plus 2 is equal to 0. Here, the quadratic equation is in y. We know that in the first step, we make the coefficient of y as 1. Dividing throughout by 9, we get 9y square upon 9 minus 12y upon 9 plus 2 upon 9 is equal to 0. which implies y square minus 4y upon 3 plus 2 upon 9 is equal to 0. Taking 1 by 2 into coefficient of y whole square is equal to 1 by 2 into minus 4 by 3 whole square is equal to minus 2 by 3 whole square is equal to 4 by 9. Adding and subtracting 4 by 9, y square minus 4y by 3 plus 4 by 9 plus 2 by 9 minus 4 by 9 is equal to 0. Therefore, y minus 2 by 3 whole square minus 2 by 9 is equal to 0. Shift minus 2 by 9 to RHS. Therefore, y minus 2 by 3 whole square is equal to 2 by 9. Taking square root on both sides. By solving, we get y is equal to 2 plus square root of 2 by 3 or y is equal to 2 minus square root of 2 by 3. Solve these for practice. Formula method. If ax square plus bx plus c is equal to 0 is a quadratic equation, then roots of quadratic equation by formula method is given by x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Example, x square plus 6x plus 8 is equal to 0. Step 1. Comparing the given equation with ax square plus bx plus c is equal to 0, we get a is equal to 1, b is equal to 6 and c is equal to 8. Step 2. Substitute in formula. X is equal to minus b plus minus square root of b square minus 4ac divided by 2a. X is equal to minus 6 plus minus square root of 6 square minus 4 into 1 into 8 divided by 2 into 1. X is equal to minus 6 plus minus square root of 36 minus 32 divided by 2. X is equal to minus 6 plus minus square root of 4 divided by 2. X is equal to minus 6 plus minus 2 divided by 2. X is equal to minus 6 plus 2 divided by 2 or x is equal to minus 6 minus 2 divided by 2. X is equal to minus 4 divided by 2 or x is equal to minus 8 divided by 2. X is equal to minus 2 or x is equal to minus 4. Example, 3m square plus 2m minus 7 is equal to 0. Here, the quadratic equation is in m. Comparing with am square plus bm plus c is equal to 0, here a is equal to 3, b is equal to 2 and c is equal to minus 7. M is equal to minus b plus minus square root of b square minus 4ac divided by 2a. M is equal to minus 2 plus minus square root of 2 square minus 4 into 3 into minus 7 divided by 2 into 3. M is equal to minus 2 plus minus square root of 4 plus 84 divided by 6. M is equal to minus 2 plus minus square root of 88 divided by 6. M is equal to minus 2 plus minus square root of 4 into 22 divided by 6. M is equal to minus 2 plus minus 2 into square root of 22 divided by 6. M is equal to minus 1 plus minus square root of 22 divided by 3. m is equal to minus 1 plus square root of 22 divided by 3, or m is equal to minus 1 minus square root of 22 divided by 3. Solve these for practice. Nature of roots of quadratic equation. We know that value of x of a quadratic equation by formula method is given by x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Here, b square minus 4ac is called as discriminant of a quadratic equation, denoted by Greek letter delta. Therefore, delta is equal to b square minus 4ac. Hence, nature of roots of quadratic equation is determined by the value of delta. If b square minus 4ac is greater than 0, then roots are real and unequal. If b square minus 4ac is less than 0, then roots are not real. If b square minus 4ac is equal to 0, then roots are real and equal. Example: determine the nature of roots. Column 1. X square plus 5x plus 6 is equal to 0. Here, a is equal to 1, b is equal to 5, c is equal to 6. b square minus 4ac is equal to 5 square minus 4 into 1 into 6 is equal to 25 minus 24 is equal to 1 is greater than 0. Here, b square minus 4ac is greater than 0. Therefore, roots are real and unequal. Column 2. X square plus 6x plus 9 is equal to 0. Here, a is equal to 1, b is equal to 6, c is equal to 9. b square minus 4ac is equal to 6 square minus 4 into 1 into 9 is equal to 36 minus 36 is equal to 0. Here, b square minus 4ac is equal to 0. Therefore, roots are real and equal. Column 3. X square plus 2x plus 20 is equal to 0. Here, a is equal to 1, b is equal to 2, c is equal to 20. b square minus 4ac is equal to 2 square minus 4 into 1 into 20 is equal to 4 minus 80 is equal to minus 76 is less than 0. Here, b square minus 4ac is less than 0. Therefore, roots are not real. Relation between the roots and the coefficient of a quadratic equation. Any quadratic equation in the form ax square plus bx plus c is equal to 0 has roots alpha and beta. Sum of the roots. If alpha and beta are roots of the quadratic equation, ax square plus bx plus c is equal to 0. Then, sum of the roots is minus b upon a. Product of roots. If alpha and beta are roots of the quadratic equation, then the product of roots is c upon a. Let us consider example. X square plus 8x plus 12 is equal to 0. Middle term 8x splitting into 6x and 2x, taking x common from x square plus 6x and 2 common from 2x plus 12. Taking x plus 2 common, we get x plus 2 into x plus 6 is equal to 0. Therefore, x plus 6 is equal to 0 or x plus 2 is equal to 0. Implies x is equal to minus 6 or x is equal to minus 2. Therefore, alpha is equal to minus 6 and beta is equal to minus 2. Sum of the roots is minus 6 plus minus 2, which is equal to minus 8. Product of the roots is minus 6 into minus 2, which is equal to 12. We can also find sum and product of roots by another method. Compare the given equation with ax square plus bx plus c is equal to 0. A is equal to 1, b is equal to 8, and c is equal to 12. Alpha plus beta is equal to minus b upon a. Minus b upon a is equal to minus 8 upon 1 is equal to minus 8. And alpha into beta is equal to c upon a is equal to 12 upon 1, which is 12. From method 1 and method 2, we get first is equal to third and second is equal to fourth. List of important formulae. Examples. Find the sum and product of roots of quadratic equation 3x square plus 2x plus 5 is equal to 0. Let alpha and beta be two roots of quadratic equation 3x square plus 2x plus 5 is equal to 0. On comparing with ax square plus bx plus c is equal to 0, we get a is equal to 3, b is equal to 2, and c is equal to 5. We know that sum of roots is minus b upon a, which is equal to minus 2 upon 3, and product of roots is c upon a, which is equal to 5 upon 3. Example, 2x square plus 10x plus 3 is equal to 0. Find number 1, 1 upon alpha plus 1 upon beta. Number 2, 1 upon alpha square plus 1 upon beta square. On comparing with ax square plus bx plus c is equal to 0, we get a is equal to 2, b is equal to 10, and c is equal to 3. We know that alpha plus beta is equal to minus b upon a is equal to minus 10 upon 2 is equal to minus 5, and alpha into beta is equal to c upon a is equal to 3 upon 2. Now we are supposed to find 1 upon alpha plus 1 upon beta. Then taking LCM, it will become alpha plus beta upon alpha into beta, which is equal to minus 5 upon 3 by 2. 2 goes to the numerator and gets multiplied with minus 5, which is equal to minus 10 upon 3. Now we take 1 upon alpha square plus 1 upon beta square. Same as above, first we take LCM. It will become alpha square plus beta square upon alpha square into beta square. Now we add and subtract 2 alpha beta. It will become alpha plus beta whole square minus 2 alpha beta upon alpha into beta whole square, which is equal to minus 5 square minus 2 into 3 by 2 upon 3 by 2 whole square, where 2 minus 2 cancels out, implies 25 minus 3 upon 9 by 4, which is equal to 22 into 4 upon 9, that is 88 upon 9. Solve these for practice.